let's talk about finance problems or any sort of analytic problem that you might have in Excel and some of the ways you might be able to solve for that. So I'm going to share my screen here. So here's the scenario. You've won the lottery. Congratulations. Good for you. That's awesome. You're getting $100 million or $5 million a year over 20 years, right? And someone offers to buy your annuity for $40 million. Do you take it? So that's the business problem, or that's the business question, and we're going to apply this a little bit later to the real world. So in this case, at time zero, or today, you're getting $5 million, and you're getting this over time. So how do you go about creating a model to help solve for this? Well, we do have some hidden columns here, so we'll do a little bit of a reveal as we go through this. Let's go ahead and unhide. So first off, let's walk through present value and what that is. Oops, that's not good. Okay.
We'll edit that out.
We'll edit that part out. So first off, present value. So first off, the present value of $5 million, since this is happening today, is $5 million. So we're not really doing much math against that. But let's walk through the formula here. First off, we have to know what our expected compounding rate is every year. And for the purpose of this exercise, we'll say there's a 15% compounding rate. So what we're doing here is taking the dollar amount, we're dividing that, and since we're not compounding, we're doing the reverse of compounding. So we're taking a divided by sign, 1 plus the interest rate, and we're raising that to the power of the number of years. So in this case, this is the opposite of compounding. We're saying 1 year out, this $5 million at a 15% rate is 1 year out. That's actually only worth $4.3 million in today's dollars. And you can do this for every single year. Now you're looking 10 years out. That $5 million that you would have received in year 10 in today's dollars is only worth $1.2 million. So this is basic net present value. Let's take that a step further then. And we'll unhide a little bit more because we really haven't answered the question yet. So here's one of the tips for you. And this is something you may have learned in finance school but forgot it 15 to 20 years ago. But this is a shortcut for some of your customers. Some of the people out there in the consulting world, your customers, your business people, rule of 72. But what the rule of 72 means is that if you take your percentage rate, in this case 15%, and you divide it by 72, this is roughly about the number of years it would take before your money would double if you assume compounding. Now, in this case, the opposite's true. This is the number of years it would take before the dollar amount is half. So in this case, $5 million, 1, 2, 3, 4, 5. Yeah, roughly at about 4.8 years, or roughly almost 5 years, it's about half. So that's one of the ways you can go through and just do a quick rule of thumb to figure out what is the difference between a 15% interest rate or a 10% interest rate. But here's the offer on the table. You have $40 million is the offer. Your lifetime paid is $100 million. So instead of going through this long exercise, another way to do that is to use one of your Excel functions. And let's show that Excel function over here on the right-hand side, and then we'll talk about how that relates to business. So right here, had we summed all of the amounts over here, we would have come, as you see, your sum equals, we would have come to 35.99. But instead of going through all this, you could have just put a net present value model in here and said, I want to take the net present value of years 1 through years 19, and I want to apply a 15% discount rate to it, which is what's happening here. B7, a 15% discount rate, and this is the periods that I want to apply to it, and I'm adding $5 million at the end because there is no discounted on what we're receiving today. And you'll see the numbers calculate here pretty well. So then the answer is, if someone's offering you $40 million and there are no other variables at play, like a variable might be, that you would spend it, or you have a death wish, or there's just a number of lifestyle variables. But just from a quick math, you could get a pretty good idea of what everything's worth in today's dollars. But let's apply that in the real world. What does that mean to a person running a business? Let's say you want to buy some new equipment for your company. And this might be like your 3-person business that you were talking about, Oz. where they need to spend $10,000 in an initial cash outlay. This could even be a lawn mowing company, a landscaping company that needs to go out and buy some lawnmowers. They're going to have an initial cash outlay, and there's going to be about $2,500 in residual costs, because there's going to be maintenance on that as time goes by. And in this case, there's a $15,000 benefit over, I should say 3 years, but over a few years. So is this a good deal or not? Well, let's take a look at some of the math. Well, first off, we have to take both of our costs, or our cash outlay, plus our benefits, and figure out what that means year over year. And as we did earlier, we could do our present value based on 15%. So let's unhide here. Rule of 72. So right now, this is a negative number. But you might ask yourself, well, Rick, that was based on 15%. And I have a 3-person company, and I know that this 15% here is usually based on something called weighted average cost of capital, right? And a weighted average cost of capital usually requires a treasury department, and the treasury department figures out the percentage of stock that you have and what the expected return is on your stock, and compare that to the debt that you have and your expected return or payments on debt, and weight all that out. And Rick, we don't have a treasury department. We're a 3-person team. I just want to know what sort of a rate I should put in there. Well, let's give you some options here. And there's another calculation that you could do to figure out what that percentage should be. What rate of return would justify the need for the purchase, or what rate of return would turn this into zero, your net present value into zero? And there's a quick little internal rate of return calculation here. And what I'm doing here is this annuity is actually just a named range for this per year number. And we're saying what is the percentage, or what is the rate of return that we're getting on our $10,000 outlay over time? And so really then your decision says, is 12% a return good enough for me or not? And so that's the way you could turn that around for a small business, just by doing some quick calculations and setting this up. And in this case, very few cells, just a few calculations, and figure out whether or not you should make this decision or not. Yeah. So with that, Oz, I'm going to hand it over to you.
Cool. All right. All right. So I am going to give this. There you go. You get 4 sriracha bottles. That is a really hot tip. That is a good one. That is takes us into a land where many of us don't venture into for Excel, but a lot of us don't need to. So that's why it's not a 5, but this is really powerful. So thank you for that.
Now, Rick, yes. I have a question for you. So, sure. So I noticed in your NPV calculation that you did that plus the amount in the time 0 spot. I didn't say that very well, but if you could explain that, because that's actually, some people consider that to be a bug in Excel, and it may have been fixed in 2013. But this is something that if you tried to do that on a financial calculator, it would work, but in Excel it doesn't. So you have to do that special thing that you did at the end.
Right. So let me explain that then. So the way the calculation works, or at least the way it works at Excel, is it applies the rate to period 1. Mm-hmm. Right, and so it assumes that period 1 is 1 period out from where you're at right now, right? However, we were saying there was going to be $5 million as a cash outlay today, right? Which means there's no discount to the dollars you're spending today. It would only be a discount to a dollar that you might spend in the future, right? You need to know what that's worth today. And so that's the reason all the math was done on period 1, 2, 3, 4 at times, at period out in the future. Mm-hmm. And that's the reason all of the net present value model was built on that. And I added back in the $5 million. I added back in today's dollars because that is at time 0.
Right.
And you would have noticed in the calculation, whenever I did the longhand calculation, and the longhand calculation, we actually multiplied it times the 0. And then we did a discount for 1 period, 2 period, 3 period. So we kind of built that in whenever we did it longhand. Shorthand, we had to add it back in at 0.0.
Okay, cool.